Everything good? Yep, sounds like it. Hey everyone, Steve Bussey. Super excited to be here in Berlin. I came from Atlanta, Georgia, which was like maybe a 10-hour trip, so that it wasn't too bad, but this is my first time in Berlin. I've been to Europe a little bit, but never to the mainland of Europe, so this is very exciting for me. This talk from Ruby to Elixir, elevate your engineering team without fear. Maybe with a little bit of fear might be more appropriate. I'm the co-founder of Supered. So this is interesting. We actually build software to help drive CRM adoption. So we are really focused on sales teams and service companies that help people adopt software. I've been using Elixir in production for several years. I was trying to think, I think it was like 2016 or 2017 is when I started with Elixir. I wish I still had access to the repos of that company so that I could see when it actually was, and I literally do not know the year. I came from Ruby company. I've done PHP in production. I've done some Node. I've done a lot of front-end stuff, but on the back end, Ruby was the main language that we used, and then we switched over to Elixir, or we added it. And I'm all in on Elixir. I started a company. We use Elixir for our full back end. I can't imagine for myself having used something different, so I'm fully in on it. And this is, you couldn't tell by my pink outfit and my pink slides. Supered is very pink, and so this gives you a little bit of, this was a few weeks ago. We were at a conference in Boston, and the whole Supered squad was rocking the pink track suits and the pink velour suits on a different day. So we had different outfits for every single day. So this was, I don't normally wear pink, I guess, but now with Supered, I wear pink quite often. So I've written 2 books. The first one was Real-Time Phoenix, and the second one, the newest one, is From Ruby to Elixir. And if you're buying books with Pragmatic, I always put the devtalk.com coupon code up there. That's the Elixir forums. They shifted their coupon code over to devtalk, so you get 35% off any Pragmatic book, which is basically outside of their specials, the best price you'll get on Pragmatic books. So I always recommend that you use that. And I have a few copies up here. So what I would say, there's some copies being given away here at the conference for the, it's you have to figure out the clue and then solve the puzzle, basically. So they're giving out some copies. I have some copies that you don't have to work for. My request would be, if this is something that you're going through, introducing Elixir to company, specifically from Ruby, it's something that resonates with you, then let's talk after. If it just, so I want to, because I have 3 books to give away, and I just want to save it for the people that are going through that, but I don't have any puzzles or anything for you to solve. Today's talk, so break it up into 3 parts. So we have an adoption story, how we introduced Elixir at Salesloft. I'll talk about some of the technical benefits of Elixir, specifically comparing it to Ruby in this case, and then how to be a driver of Elixir adoption. So you want to start using Elixir. You want to adopt it. You want to start using it at your company. How do you actually do that? I think in order to start, we have to ask ourselves, why does a new language get introduced in the first place? We have to set ourselves up for success with this. So the first I see there's obviously lots of different types of companies, but for tech, usually you break up into the startups, medium size, and the larger tech companies. And so with startups, honestly, the language that you use is just going to be what the founder wants to use. You're going to have faster, less measured decision making. It's going to be very engineering heavy in terms of who's actually doing things and making those decisions. You likely don't actually have problems at that point. You don't have scaling problems when you have $1 million in revenue and you don't really have customers that would give you those scaling problems. And also, most major languages now, PHP, Ruby, Elixir, JavaScript, they all have similar solutions to problems that you'd want to be solving at this stage. So it's actually, that's why it typically goes to what the founder wants to use. On the other hand, you have getting more into corporation role. Maybe it's more medium-sized corporations, not a Facebook company, but hundreds of employees, thousands of employees. At this point, you likely have a CTO that's separated from code. You probably, as you get larger, have CTO's reports that are separated from code and the reports that are separated from code. you have more roles that you're working with. You have PMs, you have the engineers, you have QA, you have support, you have multiple supporting roles in this engineering organization. You're going to be feeling some sort of pain of scaling and past mistakes. If you're at that phase and you're not, then you're doing something very good, so good for you. But I think most companies at that scale are feeling some sort of pain. Often making slower, deliberate decisions. So you can't just pull up one day and say, I want to start doing this, and okay, that sounds great, go ahead and do that. A lot slower decision-making process. And so this talk is going to be focused more on that corporate side. So looking at some of the technical reasons that someone might adopt a new language. One of the big ones is obviously going to be performance and scaling issues. What this often means when you're looking at a large company is reducing large server bills or increasing stability of a platform that's having active problems. So we'll talk a little bit about some of those examples. Maybe there's this idea of paying off technical debt that you've accumulated in the past. I think that's probably not actually all that achievable in the end, but that's maybe the goal. And then adding new capabilities as well, especially obviously these days with AI. People are going to be introducing AI solutions into their stack, and Elixir is actually really well positioned for that. At the same time, you have these non-technical reasons to adopt a new language. Maybe you want to increase your developer retention. If you're at the scale where you have tens, hundreds, or more developers that are all expensive to hire, expensive to replace, you spend a long time training them, things that you can do to increase your retention is good. You might want to increase your product shipping velocity, just being able to produce more with the team that you have. You might be positioning yourself for the future, so modernization. And this sounds like a little hand-wavy, but oftentimes at the CTO level, this is the type of questions that they get from their board. How are you positioning yourself for the future? What do you do? How are you going to be changing your platform and growing? And having an answer to that is probably a good thing. And then also in that same vein, showing strategic momentum. So if you can show that all right, we're pushing on this new language because by doing this, we're going to be able to introduce AI into our platform and we're going to be moving in this direction. These are some of the reasons that at a CTO level, they might be looking at adopting a new language. At least talking to Salesloft, this was one of the reasons I was asking the CTO, hey, why did you pick Elixir? And a lot of these were resonated. But the important thing here is that adopting a language is only partially a technical choice. And actually, arguably, the technical is the less important part. When I talk to engineers that are looking at adding Elixir to their stack, let's say they're a Ruby shop, oftentimes you'll see, well, it makes so much sense. It's a much better foundation. It's going to give us all these performance benefits. We should obviously do it. When in reality, that's maybe 10% of the conversation, but then 90% is the people side, and that's a lot harder to do. And so one advice here would be discover your company's whys. So observing wide-reaching problems that affect your product, looking at upcoming key features and projects. That's particularly important because you're often making this type of decision not just in engineering, but engineering plus product, and product leaders questioning, hey, why are we making a change like this? And being able to point at key projects that are coming up can give more, more authority and more trust to the project. Finding influence with the decision makers. So it's a little bit political, but working the chain of command and using that to drive the decision. But then also not forcing this artificially. So don't use Elixir just for the sake of using Elixir. Just because the Beam is a awesome foundation for product doesn't necessarily mean that it should be adopted. We have to look at the full picture and connect everything together and map the problems that we have to how Elixir can help us. So let's give real examples from Salesloft. So this was some years ago. This was 2017. And I was with them through 2021. And after basically I started introducing Elixir, that's what I worked on from that point forward. and obviously doing some Ruby stuff as needed, but Elixir was the big thing that I worked on. So at the time, there was already a microservice architecture in place with like a few small, maybe like less than 10 services total, but there was this big central monolith core for Ruby. And that's often the case that I've seen talking to companies that have developed on Ruby. So I'm going to grab my drink here. Much better. All right. This Ruby monolith was eating a lot of resources. And basically, we worked really hard at reducing consumption of resources, being more efficient, performance monitoring, and tweaking things. And we squeezed everything we could out of this, but there were just like fundamental things at the end of the day that led to us, for example, having 16 to 32 gigabyte machines with 4 to 8 cores that could run like 20 concurrent requests on them. And it was like, and that was also like the standard. It wasn't like we were like doing something bad. That was the standard for the Ruby monolith at the time. It was very expensive and wasteful. Performance enhancements, like I said, we squeezed this thing as much as we could to get performance out of it. And it was getting harder to add. And oftentimes, and this just maybe is a little bit microservice versus a monolith, but we'd be adding new features and performance problems would pop up in unrelated parts of the app. And that was one of the things internally that we were looking at. And we were feature locked on real time. At that point in time, Rails didn't have action cable. I probably wouldn't use it today even personally, but we wanted to add more real-time things. We were using some basically outsourced real-time services, and we were feature locked. We couldn't add anything else. But at the same time, it was also what I'd call political or people reasons for it. The biggest one that's worth saying is just the top engineer started pushing for it. And it's interesting to see like what does pushing for it mean? As we'd be in meetings talking about different upcoming projects, things that people are working on, he'd just say, Elixir, the beam, right? And it's like, he's sort of making jokes out of it, but he's basically like planting the seed in people's head of like, hey, Elixir can solve these very specific problems that we're having and would be good fits for them. From the CTO's perspective, his stance was, well, Elixir seems like a good partner to Ruby. We can actually have these things existing together and it will be good for the org. He saw Elixir picking up momentum at that time. So for him, it was past the point where, all right, if we adopt this, it could all blow up. It was like, all right, I think this is going to be a stable future. And at the time, we rejected other languages. So it wasn't like, oh, let's just pick Elixir. It's the first thing that comes up. It was a very measured decision around that. So taking that why, like the top engineer did, in his head, he knew all the different whys, where the org was going, and how Elixir could help. And he would propose that up, basically at the C level, about how it could actually help with these problems tangibly. And so an important aspect here is defining your goal. So one of the things you sort of see, or I should say I sort of see, is people focus a lot on rewrites. And my experience is rewrites are very hard. Even taking a small slice of something and shifting over to a different language takes so long to do and adds so much risk for things like bugs. I mean, it's an incredible amount of risk, even though there might be benefits on the other side. You also have to ask, all right, how are we going to integrate Elixir? So having things like microservices, do we want to have 2 different monoliths? Like, how are we actually going to do this? And then also keeping the goal pragmatic. So I'll get into some of the Salesloft goals, but one of those that was pragmatic is the goal was not to use Elixir for all new development. The goal was, hey, let's give the teams a choice to use Elixir and give them the capability to use Elixir. Actually, if they want to make that choice, make it easy for them. Which meant one of the goals was having a complete integration for the microservices. So everything that was related to actually writing a microservice had to be solved for. And then also a goal was to find an easy way to move engineers between different code bases without having a large cognitive overhead every time they switched. And then removing some specific software costs as well. At that point in time, like we were doing outsourced real time and it was getting expensive. And so there was some immediate benefit to take like $10K a month, cut that out in software costs, and just by doing a month of Elixir development. So how do we get started doing this? Months of just talking about Elixir casually. And I think this is the important part. Like I said, he would, the lead engineer, Ben, would just bring up sort of in a joking way Elixir to like almost like an annoying sense, but like it was like always funny. And his goal with that was just like planting the seed and be like, all right, I intend to do this at some point, and I'm like biding my time. Doing small code spikes to prove very specific technical aspects. So let's say that we're doing, all right, one of our goals is real time. That's what we're going to spike on, to know that our hypothesis that we could move all of our real-time stuff over to this is actually possible and something that we could do. But we're not worried about all the things that are going to surround it. We're just worried about that, that one specific aspect. So the first project that was picked for this, which was real-time telephony alerting, like sort of like whisper mode when people are on phone calls, was a perfect fit for this because it had the real-time aspects, it had things that would benefit from Elixir that would have been difficult in Ruby. And so we started small with that and then over time worked our way up versus trying to just take on something large immediately. So that initial project, and there were like 2 projects that we did that had very specific focused scopes for new features. So they weren't going to tie in majorly to the rest of the system, maybe just some API calls, but not like really integrated. And then after those were successful, the first integrated project was rewriting a core feature into Elixir. And that was like, all right, we're actually having to solve these real problems now. We actually, like, it's not just a spike. This is actually the code that we want other people to write. And then we basically separated these initiatives, and it proved that it could be successful in the tech stack. It wasn't just one person pushing it. Sort of had 2 different teams that were doing it simultaneously, which actually really helped to say, like, hey, this is actually possible and actually something that we can work in. And small projects are useful for validating that it can be used, but one tip here would be tackling something actually difficult, like picking the thing that you're like, I really don't want to implement this because it's going to be a pain. But by doing that, you know that all the other stuff is going to be way easier to implement. So for us, that was that very focused, specific core feature that had, it was like migrating data, there were performance trade-offs that we had with the old solution that this would solve. We had some real-time aspects, and that really validated the Elixir side of things. So let's say we do all that. Great work. These first projects shipped. It's a hit. People are like, all right, let's go ahead and do more of this. How do you actually ship more Elixir? And unfortunately, the task only gets harder. So far, we've dealt with like mostly technical aspects. Now we have to get to some of the people side of things. To start with, we have to actually integrate it into the tech stack. There were more things than I even realized existed in the tech stack that all had to be brought into Elixir. And this was like day one when we launched these features. We need to have observability, error reporting. We need to loop it into our authentication. We need to have authorization mechanisms. We need to know how we're going to be doing data access and storage. How are we going to actually operationalize the thing and ship it to production? Things that I hadn't really even thought about in a long time because they were taken for granted at that point, all had to be built from scratch in this new system. And that was just to get started, just so that we could write more Elixir. And this was a lot of work. And so if you're leading that charge, at this point I was leading that charge of actually doing more Elixir, expect to personally figure out those challenges. It is a lot of work, and it's sometimes frustrating because you're doing things that are already solved, but you need to solve them again, and you need to solve them oftentimes with not really that much support, because if you're the champion and you're the one pushing it, you're going to be the one that has to create that and create that support mechanism for other people. Oh my gosh, I feel like if someone could grab me another water, I'd appreciate that because I feel like my throat is going to keep going. So looking at actual mechanisms to roll this out to the wider team then, one thing that really worked for us was having, I would say more than one, I'd say 2 champions that are really taking on the full burden and are expected to be interrupted to help out. So, they're in the middle of writing some code for something. It's like, hey, I need help figuring out how to do this thing in Elixir. It's like, I'm going to stop what I'm doing. I'm going to come help you right now, no matter what. Then you have what I call maybe like the helper role, which is more people. But these are people that are going to be able to answer like public questions, be able to help other people when they're available. Thank you so much. And this was really important for us because by creating those helpers, we were actually creating like the next generation of champions in the company. And so over time, the people that were in this helper role while we were rolling it out to the wider team, they became the champions actually leading the charge on their teams in the future. If we just kept it as like 1 or 2 people that were really taking that on, I think it would not have been as successful. And part of that was creating the mentorship and the peer help. Specifically, I think peer help is very important. So it took a lot of time getting those initial teams ramped. And then also you have new teammates that need to be brought up to speed. They might have someone that actually gets hired, or maybe you have someone that's coming over that works on Ruby code that is going to start working on Elixir code. So mentors would give the expert guidance. All right, here is the way we do this. Like this is the truth of how we do this. But then you have peers that are actually reinforcing those practices or escalating problems that they're seeing and getting solutions to them. So just to give a perspective of the timeline here, I'd say everything was about 6-month phases, where it was like, all right, the idea of using Elixir started to propagate through the architecture team. Until the first project started was about 6 months. It was then about 6 months of doing those spike projects, doing like the 2 different projects that validated that Elixir would be usable for us. Then another 6 months before it was ready for team usage. That's figuring out all the observability, figuring out the library solutions that we wanted people to use. And then took another 6 months after that before other teams actually sought it out. So you'd have teams that say, okay, well, we'll give Elixir a shot. And then at some point you have teams that would say, I really want to use Elixir, but I haven't had the opportunity yet. Can you help me introduce it for this project? And so it took a lot more time than expected. I mean, I think 2-year type of timeline before it was actually something that people would pick up. And it was ultimately successful, but at the same time, it took a lot of time and energy. It's just like, why do I say this? Because it's important to give that perspective that if you're the one trying to do this and you feel disheartened by it, like it does take time to actually adopt a new technology. And this was, I'd say we did it pretty fast. Honestly, I felt like we did it decently fast. So I could see this easily taking longer than that. So let's switch over a little bit to the question of like what actual tech benefits do we get from doing all this? So the biggest one from a pure tech perspective was scaling with less resources. And I feel like it can't be overstated how important preemptive scheduling is and also per process garbage collection, which also means per process memory allocation. The 2 of those things together are just an amazing combination for writing programs that can scale. If you don't know things about like, I was going to include it in the deck here, but I decided not to. But if you don't know things about like how the preemptive scheduler works or what the memory structure of a Beam process is, there's an excellent set of posts. They're a little bit old now, but I think they're still relevant from Hamid Reza that really give a good overview of this in like a blog post that's with visuals, and it's very helpful. So With that, we also have this idea of achieving some ideal performance per machine. With our Ruby machines, we were, like I said, it was like 24 concurrent requests for these big boxes. In no world is that ideal performance per machine. And I think the big thing that I don't actually see talked about all that much, but this the act of having more concurrent, simultaneous app requests per server. And create this sort of crappy visual to think about it. The top is a Rails app powered by Puma for the app server. And the bottom would be like an Elixir app powered by Phoenix, or but it's a plug app. And in Rails and with Puma, you basically have to think in this concept of slots, which is you have your app, and you have like your main process that starts, and then you're typically going to fork off a certain number of other processes. So typically you do like 4 to 6 other processes that you're forking off. And then each of those forked processes is going to have a given number of threads that are actually serving requests. And this is how you get a little bit of like the concurrent aspect, where it's not exactly parallel, but there's some concurrency with those threads. But that's it. If you have 16 concurrent requests and the 17th request comes in, your server cannot accept it. It can't even start working on it at that time. It's like not possible to do that. So typically, when you run Rails and you're trying to squeeze out performance, you're looking at things like request queuing are very important numbers that you're looking at. And you just hit this, like we hit this wall where it's like we cannot get more performance out of this because you can't increase the number of processes because the memory overhead was huge. And it's basically maxed out. You can't increase the number of threads because it doesn't actually scale that well with threads. So you're basically maxed out. In Elixir, and I'll use Phoenix as the example here. I was looking at like what the default was, the number of like acceptors and connections that Bandit accepts now for as the default, and it's so high that it actually doesn't matter. It's like thousands is the default, and I think it's like 16,000 per acceptor, and then you have a number of acceptors that you're running, and which is like 100. So it's like just a huge number of connections. And while you may not want that many simultaneous requests, the fact that you can actually do that means like when you're hitting these high performance needs, you actually have the ability to squeeze out more performance in a way that we literally could not do with Ruby. And there was a recent tweet from DHH that, I mean, it's good. Like, they had 5,000 requests per second, and they had 500 cores at max load. And so he's like, all right, this is how we'd spin that up. Given their revenue, given everything else, doesn't really matter that much in the grand scheme for them, the cost of that. But my initial thought when I read that was like, it doesn't seem like that much. And Peter Ulrich had a similar thought of like, that seems very inefficient. And he brought up Bleacher Report replacing 150 Ruby servers with 5 Elixir ones. And I think this is, to me, the very specific technical thing that I like drill in on when I'm looking at Ruby versus Elixir is this idea of like how the actual requests get served and the fact that you can do so much more with Elixir. This was Veeps. They had 20 Rails nodes, not really that big of a deal, but they were able to do it with 2 after the fact, so like 10x less, which is often what I see, like a 10x reduction is sort of like what I expect to see when I see these posts. So that's a very specific thing that like that's what I drill in on if I'm looking at a technical benefit. Co-located app types. One of the really cool things is that you can actually run your web sockets, your workers all together on one server. That's not really sometimes possible, and it's definitely not advisable in Ruby. So we just had massive resource overhead from like the best practice is to have separated resource types, and it got very expensive. First-class WebSocket support, which I think is, obviously with live view, it gets really important, but just with real-time in general, I think the Beam's process model, to me, is about as good as it gets for WebSockets. I can't think of too much more that I would want. specifically looking at performance and error isolation are, it's to me probably like the best. Easily scale to tens of thousands per server. We weren't even trying that hard, and we scaled to like 50,000 connections per server on average, and like we didn't try. We were just happy with that, and we didn't try to get any more. Versus literally hundreds for like Action Cable would be the standard. Built-in clustering and messaging is huge. If you're building high-performance systems, you're at that point of trying to figure out scale. Being able to message across the cluster gives you so many more options that you wouldn't have otherwise. If you're using WebSockets, you need to have some sort of clustering. That could be like Redis or something, but when it's built in, that's just another thing to not really have to worry about once you get it working well. The idea of letting it crash is actually more about tell it how to start. Fred has a blog post about this, and I forget the title of the blog post, but it's sort of around that idea. Basically, you get to control how your processes start and how they initialize, which makes it possible to actually consider your failure modes and how you want to recover from them in your app. And that can reduce the number and durations of incidents. If you're on call, if you're wearing a pager for a week at a time and you can cut down incidents and let the system just self-heal without needing to page someone, that's pretty useful, especially as you get into a larger corporation. I think the functional paradigm is important as you are bringing Elixir out to the team, because while it's functional, it's also pragmatic. It's not like it's not the same level of functional as some other languages. The functional paradigm it has and the immutability make it clearer to follow data flow and how data is modified than it would be in Ruby. And so that was one of the things we struggled with as we scaled our Ruby app, is people would try to debug requests, and they'd have to mentally hold in their head everything that's happening to this data as it goes through the request, and you just don't have that same problem because of the immutability side of Elixir. And this just makes it easier to maintain programs and to onboard new developers, which is huge when you're thinking about it from like the businesses side of the equation. Like those are things that they care about greatly. Gen servers, obviously encapsulating data, behavior, plus the time life cycle. And this was the key thing for us. This concept does not exist, at least easily, in Ruby. Now with like Ractors, which are Ruby actors, it's changing a little bit. But there were things that we wanted to do specifically for like performance benefits that would have been 15 to 30 minutes in Elixir that we literally could not build them with like the smartest people in the room trying to figure out how to do it. It just like the paradigm didn't work. And so Elixir makes things possible. Even if we don't need all of those features, they're there when we do need them. Most of the code that we wrote was boring, but like 2% of it really helped us achieve high scale and uptime. I think that's the important thing. It's like we're not always writing crazy code, but when we need it, we can actually do it. And the way I think about this, like we wrote sub-programs in our Elixir apps that would, like we didn't think that way and we didn't write code that way in Ruby. And so this is a phrase I use. I don't know if it's a good phrase or not, but I like it. Build cities, not skyscrapers. It's not about monoliths. It's about my ChatGPT image that has typos, but it's endearing to me somehow. With basically, in a Ruby app, you have this single stack that your request goes through. Request comes in, the ground floor, goes through the whole stack, goes back down, comes out, and the request is served. So when you want to introduce things, you always have to thinking, all right, where does this code fit into the stack, and how does that work out? With Elixir, while you can build like this monolithic core and you have you don't have to think this way, but you can actually build these like sub-programs that are all running on the same beam, that are able to communicate with each other, and you can actually write entirely different types of applications that way. And for me, it really changed just like how I view programming, which is why like I'm so into Elixir. And let me do a time check. Cool. All right, so a basic example of this, in-memory caching. We were doing caching in Ruby to solve performance problems. But we were extremely limited on how those caches coordinated with each other and also how cache invalidation worked. And there were certain things we wanted to cache. For example, in a multi-tenant SaaS application, team ends up being something that gets used all the time. And we'd be loading team 10 to 20 times per request. Now, we had ways of caching that so that it wasn't such a big deal per request. But then you're making, 3 to 6,000 requests per second, and now all those requests for team actually start becoming a problem. And we did not trust the caching that we would be able to write in our Ruby app, and so we just sort of left it, even though we knew that we could shave off a pretty significant amount of time on the whole server by solving that problem, which we were able to solve in our Elixir apps you can solve that problem in 30 minutes. And another specific thing we did with that is reducing microservice web request counts. So we did a lot of in-memory caching that let us not make other requests, but we also trusted the caches that we had, and so it wasn't as big of a deal to do so. A more complex example is serializing an API. So we had one project that required to make, let's say, 10 API requests at the same moment of time. And oftentimes those requests would be duplicated. It was just sort of how the UI worked. And doing that basically meant we were going to be slamming the back end with just a ton of requests. And we could serialize that on a server, and you'd have as many servers as we have is probably how many requests are going to go through. So maybe you go from 10 to 4. But we really wanted to have one request go through. So we were able to use a gen server and hash ring to serialize those API requests. So if you were requesting a particular asset for a particular team, it would always go through the same server, and it had a gen server that would resolve it, and it would reduce the request down to guaranteed 1. And this would have been impossible for us to write in Ruby. We wouldn't have been able to write that. So while we had all these benefits, we hit some pain points. So learning Elixir was hard for us. Initial programs, bad, objectively bad. And writing them was also more difficult than it would have been if we just wrote the feature in Ruby. So, there's some political movement between product and engineering about hey, why is this thing taking so much longer? And that's something we had to be committed to. I personally focused way too much on learning OTP versus learning tools and then learning OTP later. And this caused me, I had 4 false starts of actually learning Elixir, because I was trying to write some things with TCP sockets and gen servers and just trying to do different things. And then one day I was just I don't get it. And I had to sort of reset myself and say, all right, I will understand this stuff one day, but right now, maybe I'm not going to understand it, and I'll come back to it later. And bringing the rest of the team up to speed took a lot of time, because they all were going through similar thoughts as they were learning Elixir. None of them knew Elixir. So yeah, that's also important, I guess, context. No one on the team knew Elixir. We didn't hire someone that knew Elixir and brought them in. We didn't have any type of really consulting on it. We just sort of did it, and we made do with it. We had too much custom OTP things. So one team just jumped in and started writing something. Yay, celebrate that the fact that they did that and were able to do that. And they wrote a lot of custom gen servers that all talked to each other and all had dependencies on each other, and it was very difficult to unwind one day when we realized we need to unwind some of that. And that final product was much more fragile than it actually would have been without those things. Because at that point in time, they didn't have enough context to know the best practices. And honestly, it would have been better served just leaning on libraries. Phoenix, Oben, CacheX, and then expanding custom solutions over time versus jumping right into custom solutions. On the operations side, we ran into a few headaches. It wasn't actually that bad, but the operations team did not understand how Beam apps run. Everything was always compared to the Ruby apps, and it led to a lot of difficulty understanding resource utilization, memory consumption, how cores are used, and it took a lot of patient education and guidance on how to actually operationalize this. And sometimes it was a trust me moment, hey, I know this doesn't seem right, but trust me, it is. And some of the feedback we got was I'm not interested in that. I have zero interest in learning Elixir. I'm very happy doing Ruby. I've spent the last 15 years writing Ruby, and that's what I'm going to do. If our goal was 100% adoption, that goal would have failed because we had people that like literally would not do it. Or I guess they would have quit if they were forced to. But it was never a mandate. We didn't say you had to use it. Someone said, I'm not interested in it. Okay, let's talk about why that is and understand it. Okay, like we respect that. Upgrades over time, we struggled with just keeping our Elixir and Erlang versions up to date. Some of the libraries we used required fixed OTP patch levels, and that was painful. Intel to M1 transition was very hard that we had fixed OTP patch levels, and we couldn't bring in a lot of those changes that were necessary for making M1 smooth. We got through it all. Some of the problems that I often hear about why people don't adopt Elixir didn't happen. We didn't have hiring problems with it, honestly. We had new hires seeking us out and saying, hey, I actually saw that, I've seen y'all doing conferences, and I see y'all writing, and I see, adopting Elixir, and I actually just want to write Elixir. And we had a lot of hires that would seek it out to specifically work on the Elixir side of things. Internal team ramping, we had some difficulty up front, but once we had those examples built for people, existing Ruby team members ramped up really quick. So we had to invest in internal libraries, also that integrated the style between Ruby and Elixir, which is a whole separate talk. But basically the idea of that is you would look at one of our Ruby files, look at one of our Elixir files, and they would look 95% similar. And we did that very intentionally. Few library issues. Libraries for us were generally stable, solved all the problems we needed them to solve. We got hurt on Kafka a little bit, but I think that story is probably better now. But that definitely got us. So the final part of this talk is about how you can drive adoption. If you're wanting to introduce Elixir at your work and maybe you've been struggling with it, or you're just getting started and you're like, all right, what can I do to actually drive this? Other than the things we've talked about so far, let's look at why it might fail. So the first big thing is the tech's not implemented correctly. If you're going to adopt Elixir, you do have to figure out, all right, how's this going to fit in? What's the correct way we want things to actually, how we want them to work? How do we fit it into our whole system and look at everything together? You have to solve that. You might have goals that aren't actually achievable, which would be, looking at someone could set it up and say, hey, we want to do a rewrite of this, and it's going to just be not achievable to do that. You could have lack of training and support. We had to take a lot of time on this, and so if we didn't do that, we would have failed. Other engineers feeling like more friction than value is being added, and then all that leads to buy-in slipping over time. So one of the frameworks that my co-founder uses when he talks about CRM adoption, he gave it a nice little acronym, CREDIT. Celebrate, remind, enforce, define, inspect, and train. Not really in that order, but we'll go through it in that order. So this is very important. Celebrate people that are trying to adopt Elixir, that are trying to learn it. Highlight them, call them up to their bosses, make someone look good to their boss by talking about how good they're doing with this, a new Elixir project. Make them feel like a champion for using Elixir the right way. And this happens by calling out normal, everyday things. Not the end of the project comes around, we all did a great job. It's hey, that pull request you did was really awesome. I like seeing these specific things, and really celebrating that. Reminding people. Using code reviews to remind people about best practices, proactively sharing examples of excellent code that you want to replicate around the product, and talking about these foundations repeatedly. It takes so much time and so much reinforcement for things to click. Enforcing different aspects. So we want to find and correct bad code before patterns take root. We want to automate style and best practice using tools like Formatter and Credo. Define, so maybe this is the thing you should do first, but you have to discover the right mix of libraries and custom solutions for your system, integrate those into the back end, create the best practices for the rest of the team. This takes a lot of work, and this is sort of the foundation of how to actually make the tech side of things successful. inspect. You gotta know, how are people feeling about, adopting Elixir and starting to write code with it? Are they hitting problems that's going to cause adoption to fail? Get ahead of these things. Don't let them come up in retros. Come up proactively instead. And then train. I mean, you probably have to spend 2 times more than you think on doing training. And then you probably need to spend 2 times more than that. Docs, videos, meetings, people are going to need everything to get brought up to speed. It takes a lot of work to put all that together, but it was also always appreciated. And then a key thing here is also starting to invite others on the team to lead training. Start turning those helpers into champions, and that's really how you can propagate Elixir across. So wrapping up here, the thing I came away with as I was reflecting on all this is that adoption's 90% people, 10% tech. So we need to over-index that people side, and we won't regret it. So thank you.
Thank you.
Wrap up.